Hello and welcome back. Okay, in this video, I want to talk to you about the Amazon S3 Lifecycle Management Service. Now, this is a service that can help you manage the lifecycle of your data that you're storing in S3. It's all too easy to store any amount and vast amounts of data into the S3 platform and then just forget about it. The problem is this has a direct impact on your cost and could also lead to potential security issues. So let's take a look at lifecycle management in this video. Regardless of the amount of data that you store in an S3 bucket, the fact remains that each and every data item, each and every object that you store in an S3 bucket can be assigned a particular storage class. You could have lots of data in the standard storage class, some of that data in standard IA, and maybe a large volume of data in the Glacier storage class, depending on the type of data, the type of object it is. So all of our new recipes for the Richer Roast coffee shop business is being stored in the standard storage class because it's been regularly accessed by Becky, our head chef. We've got some old data that has been stored in the standard IA. Perhaps it's one that Becky wants to refer to instantly if she does need access to it. And then there's some other sets of data and very old recipes or images that's been stored in Glacier for historical purposes, auditing, and so on. As you can see, you can store an unlimited amount of data in S3 and you can categorize them in their various storage classes. The thing is, as time goes by, a lot of these recipes may become old recipes that are no longer used. As we progress, as we improve our recipes, as we use AI to come up with some new bright ideas, whatever it might be, you're likely to experience a scenario where a lot of the current data becomes non-current or not used or rarely accessed, in which case you want to transition those data sets and those objects into cheaper storage classes. And you want to automate that process. You don't want to manually have to move stuff around in your S3 bucket. And that's where lifecycle management comes in. So let's talk about how it works. So with lifecycle management, you create something called lifecycle rules. And these are a set of transition and expiration rules. Transition rules basically mean that you transition from one class to another. Okay, and the transition action will perform as per the rule. So you could say, my standard data, the data that I'm currently accessing on a regular basis that I need instant access to, I will stop using it so often. I will not access it on a regular basis, perhaps after a month or perhaps after 3 months. So after a month or after 3 months, you want to transition it to maybe the standard IA storage class. Maybe after a couple of years, you're really going to access that data. Okay, and you're only going to access it if you just want to reference something you did in the past, in which case you probably want to transition it into a Glacier storage class, which will be much cheaper. It will store your data highly durable with 11 nines of durability, but it means that you don't have to spend so much on the cost of storing that data. You also have expiration actions. A lot of data becomes irrelevant or unnecessary after a period of time. Financial data or any kind of, data that you're storing for your organization may become irrelevant after 7 or 10 years, depending on the regulatory body that governs the industry that your business operates in. Okay, and as a result of that, you probably want to ensure that you purge and expire and delete that data entirely after the 7 or 10 year period. It ensures that you reduce your cost on bulk storage, but also it might be a security measure that you might want to consider as well. Now, one of the things that you can do with lifecycle rules is you can apply separate rules for current versions versus previous versions, so non-current versions. And so what that means is that your current versions, maybe you need instant access to that data, so you want to transition it from standard to standard IA. But the non-current one, we probably don't need to put it in standard IA. We can just ship it into Glacier after 60 days or 180 days, whatever your parameter is. You also can apply your rules to the entire bucket or a subset of objects using prefix and tags. So this becomes really brilliant because you might have certain data sets where the rules differ from data that belongs to other prefixes and tags. Okay, so you can apply your rules to the entire bucket, a single rule, or you can have rules for different subsets of your data. Let's take a look at an example. So you've got the current version of some Excel documents that you're maintaining for your organization. It's in the standard storage class. It's recently been created and uploaded to S3, and you're accessing this data on a day-to-day basis. After 30 days, it's a bit less relevant, okay? And so as a result of that, you might ship it into the standard IA storage class. After, say, another 60 days, you decide that, well, you're going to access this data very rarely, okay? So maybe we can ship it into the Glacier Flexible Retrieval Storage class, where if we do need instant access to it, to that particular Excel sheet, we could use that expedited retrieval option. If not, we can use the standard retrieval option, which requires us to wait for 3 to 5 hours. And then perhaps it's totally irrelevant after 365 days, in which case you can just put it in the bin, okay? Expire the data. The rules might differ if you have a non-current version of your data. If you've got versioning enabled, this is the current version. Perhaps the previous versions, the non-current versions, are less important now that you've got the current version updated and ready. You may still need the non-current version for 30 days in case you need to go back to it because you made a mistake. But then perhaps after, let's say 180 days, you're pretty confident that your current version is the right version and you can chuck it in the bin again. Okay, so there are different rules that you can apply. You can create these rules based on the industry that you're in, your business requirements, and the policies that your organization follows in terms of managing data lifecycles. Now on AWS, we've got the Lifecycle Management Service, which allows you to transition using a waterfall model across the different storage classes. So we've got standard here at the top. This is obviously the default storage class, but you can transition automatically from standard to standard IA, intelligent tiering, and so on and so forth. And if we take a look at the waterfall model, from the standard storage class, you can transition into IA, intelligent tiering, one zone IA, Glacier instant retrieval, flexible, and deep archive. Okay. You do need to be aware of the minimum storage requirements, though we'll come on to that in a second, but you can transition using a waterfall model that way. If you've got data in the standard IA storage class, that can be transitioned into intelligent tiering, one zone IA, instant retrieval, flexible retrieval, and deep archive. If you've got data in intelligent tiering, you can transition from intelligent tiering into IA, into one zone IA, Glacier instant retrieval, flexible retrieval, and deep archive. If you've got data in one zone IA, you can transition into Glacier flexible retrieval and deep archive. In this particular case, you cannot transition into Glacier instant retrieval. So there are certain limitations and caveats you need to be aware of, and I'll highlight some of those in a second. If you've got data in instant retrieval, you can transition into flexible and deep archive. From flexible retrieval, you can go into deep archive. What you would have realized is that you can't go in the opposite direction. So if you've got data in standard IA, you can't transition back into standard, okay? Or if you've got data into one zone IA, you can't transition it back into intelligent tiering. So these are certain things you need to be aware of. It follows this waterfall model. Let's talk a little bit about the exceptions next. So some of the exceptions that you might need to be aware of is that S3 lifecycle transitions objects to the Glacier Flexible Retrieval class and the Deep Archive classes asynchronously. So what that means is that there may actually be some delay between the transition date in the S3 lifecycle configuration rule and the date where the actual physical transition takes place. Okay, so you just need to be aware of that. Another thing that I want you to be aware of is that there are some unsupported lifecycle transition. Obviously, you know we can't transition backwards, but for instance, you can't transition from any of these storage classes into the reduced redundancy storage class. Okay, this is a class that is highly not recommended by AWS, but it still does exist. Okay, so you can't transition into the RRS class, right? And also, for instance, there are certain storage options within the intelligent tiering storage class that have limitations and how you transition into them. So remember, with the intelligent tiering storage class, we've got standard, and then we've got infrequent access, and then we've got subclasses there further. So some of those classes you can't transition from easily to all of the other classes. So as an example, the intelligent tiering storage class, archive instant access tier, from that particular tier, you can't transition into one zone IA. Okay, so whereas the standard intelligent tiering storage class, you can move it into one zone IA. The archive instant access tier of the intelligent tiering storage class, you can't move that into one zone IA. Okay, so some of these caveats and limitations exist, and you need to make sure you're familiarizing yourself with them. so that you know how this works in the real world. Another example is in the intelligent tiering storage class. An optional class that you have, an optional intelligent tiering storage class, is the deep archive access tier, if you remember that from the previous videos. So from that one, because that's a deep archive access tier, that can only be transitioned into the Glacier deep archive storage class. You can't transition from that sub intelligent tiering storage class to OneZone IA, instant retrieval, or flexible retrieval. Few other things to be aware of. Okay, so if you have really small objects, and that's less than 128 kilobytes in size, they are not transitioned by default. This is a fairly new change in 2024. Okay, so if you've got objects less than 128 KB, those objects are not transitioned by default. Now, the reason for that is because there's a cost involved in transitioning every single object. And usually the cost of transition would outweigh the cost savings incurred. So it doesn't make sense financially. However, you're still welcome to apply what's known as a filter, an object size filter, where you can set a custom minimum and maximum size. So you could drop the 128 kilobytes down to 60 kilobytes, for instance, if you wanted to. But bear in mind that economically or financially, it might not work out in your best interest. The other thing to be aware of is that there are minimum storage hosted. So for instance, there's a minimum 30-day storage before you can transition into standard IA or OneZone IA. So that's from the standard class. So data needs to reside in the standard class for at least 30 days before you can put it into IA or OneZone IA. You also cannot use a single rule to transition into IA and then immediately into Glacier. Okay, so once you put data into IA, it needs to stay in IA for 30 days before you can move it again to a Glacier storage class. So in effect, in the standard classes, across the standard classes, that's 60 days. Also, the Glacier instant retrieval has a minimum storage duration of 90 days. Okay, so again, there you would have to have your data in there for 90 days before you could transition again further down in the waterfall model. Okay, so that pretty much brings us to the end of this video. Lifecycle management is a really critical feature that you want to be aware of. And you can use that in real world scenarios when you're doing all of your operational efforts and you're building solutions for your clients. You want to make sure that you incorporate lifecycle management so that you're cost effective for the client that you're working for. So next, I want to talk to you about what happens with incomplete multipart uploads. Now, in a previous video, we spoke about what multipart upload is. It's a service that allows you to break up your large files into smaller chunks and have those chunks uploaded in parallel. Once it is uploaded into the S3 bucket, those chunks are then basically brought together to complete the multipart upload and to create your file in the bucket again as a whole. Now, with multipart uploads, obviously what happens is if a particular part fails, those parts can be restarted, so you don't have to try and upload the entire file over again. However, there are situations where you are uploading really large files, and for whatever reason, some of the parts get uploaded, but the remaining parts might just fail and just not upload. And you may have a deadline in which to complete all of these uploads, or those files might have become corrupted, or any other network outage reason might prevent you from completing those uploads of the incompleted parts. And so what we have is in the bucket, incomplete parts that cannot be used to form the actual file anymore because the remaining parts are just not there. Now, these incomplete parts are occupying storage space, which means ultimately the business is going to have to pay for that storage. With lifecycle management, what you can do is you can monitor your bucket so that if there are any incomplete multipart uploads, and the upload hasn't completed over a specific period of time, like say 7 days or whatever it might be, you can have the lifecycle management delete those incomplete parts so that they do not continue to occupy unnecessary space in your S3 bucket. Because the chances are you might have resolved the issue and then perform a re-upload and forgotten all about those incomplete parts. Those tend not to show up in the standard AWS Management Console. And as a result of that, you've forgotten all about them, but they're still occupying space and still costing the company money. So I want to jump into the AWS Management Console and show you how to set up lifecycle rules to delete incomplete multipart uploads. Okay, so here we are back in my AWS Management Console. I'm in the Amazon S3 Web Management Console. And if I go to my RR large buckets, you'll see that what I'm looking at is just those first two uploads that were successful as per the previous video in this section of the course. Now, this particular bucket does have those multi-part uploads. Okay, go to management, and under lifecycle rule, we're going to create a new lifecycle rule for this large bucket. And I'm going to call this one delete incomplete uploads. Okay, so I'm going to apply this to all objects in the bucket, and I'll just need to acknowledge that I'm applying it to all objects in the bucket. But if I scroll down, I can set up a lifecycle rule to delete expired object delete markers or incomplete multi-part uploads. Okay, so we're going to go ahead and click on delete incomplete multi-part uploads, and I'm going to set the days to maybe 7 days. So if I'm not able to complete the file upload of the large file within 7 days, I would like the lifecycle management service to delete those incomplete parts. And then you go ahead and just simply create the rule. And here we are, the rule delete incomplete uploads has been successfully added and the lifecycle configuration has been updated. So what's going to happen is after 7 days, if those parts haven't been completed, then lifecycle management will delete those incomplete parts. Okay, that pretty much brings us to the end of this quick demo of how you can set up lifecycle management to manage your incomplete parts. I'll see you folks in the next video. Thank you.